The next tool that will help us understand fluid under motion is your velocity profile. So basically, the basic idea over here is that if you have, say, a stream of something, any fluid, you take a cross section, right, and talk to the particles. So actually, let me explain with an example. Okay. So the basic idea of velocity profile is this. So I have a pipe. So this, guys, this represents a pipe. Okay. So if I happen to cut a pipe, and so when you cut a pipe, what happens? So if this is a pipe, if I cut it, you will get something like this. If the pipe is circular, you'll get something like this. And you will have, of course, particles just over there. If there's something flowing, that will show up. So we have a bunch of particles standing over here. Now, if I happen to talk to them, so if I happen to ask them, tell me your velocity, right? If I happen to discuss with each of them their velocity and I map it, okay? So this guy has this velocity, this guy has this velocity, this guy has this velocity, and so on and so forth. And if I join all of them, it can be anything, guys. I'm just making some random thing over here. It can be anything. If I happen to join all of the heads of the velocities, this line is your velocity profile. That's it. Okay. So those happen to be, that line happens to be your velocity profile. It won't be a line actually. It will be a surface when you talk about cutting a actual pipe and talking to the particles. That would be so. But in this case, it will be a line. For this diagram, it will be a line. So that's the basic idea of velocity profile. Let's see what I have come up with over here. The text, that is, if you have a cross section of a flowing fluid at a particular instance in time and measure the velocity, that is both the speed and direction, at different point across the section, then map or plot those velocities, the resulting pattern is called the velocity profile. So I have an example for you guys. This is a velocity profile that I found for wind turbine. Okay. Right. Yeah, we can't understand much about it as of now. So I will be going and showcasing you guys this. So using velocity profile to understand non-viscous flow and so on and so forth. So we'll be doing that. For now, I'll just define it and give you guys a brief idea. So as a definition, velocity profile is the surface formed by connecting the tips of the velocity vector of fluid particle within a cross section. Depicts how velocity varies across the flow area. Okay. So that would be your velocity profile. So till now, we have had a quick view about your fluid dynamics. So to understand that, we have to make use of streamline, the idea of streamline. And the next thing that we are using is your velocity profile. Okay. So velocity profile, I think you guys can write the heading, and this is pipe, by the way. That's how a pipe is represented. And then I map it. So the surface, it will be a surface. Okay, guys, if you stand over here and see it, it will be a surface. Now we're standing exactly perpendicular to the stream. And then what you guys want to write over here, it's left to you.